everyone, my name is Larry. Today I'm going to introduce my project that is powered by VEX V5 pods. My project is called PID Controller Demo System. It can help us learn about how robots can move accurately using math, motors, and sensors. Here's my setup: a strong metal frame, a V5 Smart Motor connected to a wheel through a 6-to-1 gearbox. I added metal gears to make the wheel heavier. This gives the wheel more inertia, so it moves more like a real robot that's hard to stop quickly. There are 4 knobs made from rotation sensors with small gears. It is used to adjust the values. A bumper switch is used to start and stop the movement. And best of all, it's the V5 screen. It shows all the values live, so I can see exactly what settings I'm using. What the knobs do. Each knob controls a key part of the system. Target angle. It sits where the wheel should turn. Speed limit. It controls how fast the motor can spin. KP, proportional gain. It makes the motor respond more when the wheel is far from the target. KD, derivative gain. It helps slow the wheel down as it gets closer, reducing overshoot. Now let's do something fun. I will show you how to tune the PID system. This is how we usually do it. First, I set KP to a small value and KD to 0. The wheel now moves slowly and might not even reach the target. Next, I slowly increase KP. The wheel now moves faster and more powerfully, but it might start overshooting or shake at the end. Now I increase KD. You'll see the shaking or bouncing reduces and the wheel stops more smoothly. You can start decreasing KP. Now I can adjust the target angle and speed limits to test the system reacts under different conditions. And here's something cool. Every person might find a slightly different combination of KP and KD that works best. That's the fun of PID, finding the perfect balance between fast and smooth. Thank you for watching my demo. I hope you learned something cool today.